Welcome back to the Obby series. In today's episode, we'll create the system for saving players' data. This means that players can play through our Obby, reach different stages, leave the game, and whenever they rejoin, their data will be the same as when they left. So let's hop right into Roblox Studio and begin working on this. Now, the first thing that we're going to do is basically create a layout of what the player's data will actually look like. Now, we're actually going to set this up inside of the replicated storage. So inside of here, we want to create a brand new module script, and we're going to rename this to be called player data. Inside of this script, we'll rename the module variable to be called shared. With that being said, most of the code that we're going to write inside of the script is actually going to be above our shared variable. Now, the first thing that we're going to do inside of the script is actually create a type. If you've never created a type before, don't worry. It's pretty simple, and as you follow along, you should really get the hang of it and easily understand what we're doing. Now, to begin creating my type, I'm going to use the keyword export. We use the keyword export while creating a type because that will allow us to share the type from this script into other scripts which require this module script. Considering how module scripts normally work, if we want to share something with other scripts, we would need to attach those things to our shared variable, because of course that is what is returned to the scripts which require this module. But when it comes to types, it's a little bit different. Instead of storing that type inside of a table, we just use the keyword export, and then we create our type. Now, to create a type, we actually have to use the keyword type. And now after this, we specify the name of the type that we're creating. And the type that we're going to create is going to be called player data. And we're actually going to set this equal to a table. Now inside of this table, we want to include a few key value pairs, and those will actually make up the data that we store for each individual player. Let's think back to the last episode when we actually created the leader stats. When we created the leader stats, we added a number value to there. And what was that number value for? Well, that number value was for what stage the player is actually on. So of course, when it comes to storing the player's data, we are going to want to save whatever stage they're actually on. So for our key inside of this table, we're going to say stage. Then we'll use a colon, and now we'll specify the type of the value that will be stored with this key. And what do you think the type of this value is that we will store with the stage key? Well, if you guessed number, you're correct. Now, the player stage certainly isn't the only data that we're going to be saving for the player, so let's add another key to this. Another piece of data that we want to save about the player is how many deaths they actually occur. And what do you think the type of the value will be for this? Well, if you guessed number, you were correct once again. Now, there's a lot of other data that we're going to be storing for the player. I'll actually give you a sneak peek into what our data table will look like by the end of the series. So, in addition to the player stage and the amount of deaths that they have, we also want to track the amount of times that they've rebirthed, how many skips they have, what codes they've redeemed, what their settings are toggled to, which game passes they've purchased, and even if they've subscribed to our VIP subscription. Now, considering we're not going to be really implementing most of these things in this episode, I'm going to go ahead and remove all of those and only keep the stage and deaths. Of course, when we set up those other systems, we'll come back and add the player data inside of here, but for now, I don't think we should get too far ahead of ourselves. So, now that we've created this type, the next thing that we want to do is actually create a variable of this type, which we'll use as the player's default data when they first join our game. So for example, when the player first joins our game, we want them to begin at stage 1, and of course they should begin with 0 deaths. So we need to create a variable to specify that information. So we're going to create a local constant variable, and what I mean by constant is the value of this variable will never actually change. Pretty much, this variable will only ever be read or viewed by other scripts. It will never actually be modified, though. Now, when it comes to creating a constant variable, the only real difference here is that we write the name of the variable out in all capital letters. So we're going to call this variable player_data. Now that we've typed the name of this variable out, we can then use a colon, and now after this colon, we can specify the type of this variable, which will actually use the player data type that we just created. And since we set this to the player data type, what is the player data type? Well, of course, it is a table. Now that we've created this variable, we can see there is a lot of underlined in red here. So this is giving us an error because we did not include all of the things inside of this table, which we need to, for this variable to actually be of this type. Now, I think right there is a great example to highlight why we actually want to use types. Types are extremely useful because they really help you understand what your code actually does, and they can easily prevent you from making different mistakes, like forgetting to include different things inside of a variable that we need to include. To better show you this, let's just remove the actual type of this variable, and now we can see the error is completely gone. The thing is though, is that this is really bad. because now this variable is missing the stage and def's key value pairs. And because of that, when we actually go to use this variable, we'll encounter some different errors because of this. So that's why we always want to try to use type checking. With that being said, let's go ahead and add those key value pairs to this table that we need to. First, we'll go ahead and add stage. So we'll go ahead and type out the word stage. And as we're typing it out, we can actually see that Studio is suggesting the word stage to us, and it even says the value of it is a number. So that's another really helpful feature of types, is that it basically makes Studio a little bit smarter. And because of that, Studio is able to give us better auto-completion results and really make our scripting experience a lot easier and more intuitive. Anyways, now that we've added the stage key, let's go ahead and set the value of that. What stage do we want players to start at when they join our game for the first time? Well, we'll start them off at the first stage. Then we'll include a comma, and now let's go ahead and add defs to this. And of course, for defs, we'll start all new players off with 0 defs because they've never died before. And now that we've done that, we can see all the red underlines have been removed because we've added all the key value pairs to this table, which we needed to. Now, in the future, as we set up different systems, we will come back to this script and we will add new key value pairs to the player's data. But for right now, we are done with that. The last thing that we have to do inside of the script, though, is we actually have to share around the player data variable so that we can use it in other scripts which require this module. And this might seem a little odd to you, but it's actually incredibly simple to do. All we have to do is say shared, and then we can basically just add a variable to the shared table. So we'll go ahead and call this player_data, and we'll set that equal to the player data variable that we created a little bit above this. Now you might be thinking, well, why do we create a local variable for the player data instead of just creating it directly inside of the shared table? The reason for that is because you cannot actually specify the type of a key or a variable inside of a table. So we'll say, for example, shared test, and then we'll use a colon, and then let's try to set the type of this to player data. Then we'll say equals, and we'll create a table, and now we can just see there's a lot of red underline, and we just kind of get a weird error. So yeah, unfortunately, we're not able to specify the type of a key inside of a table like you probably expect that you would be able to. So that's why we created player data as a local variable, because this is the workaround. We create the local variable, which allows us to specify the type, and then we can easily share it with other scripts by simply adding it to the shared table, just like this. Now, we're pretty much done in here. I think one more thing that I might do is actually rename both of these variables, because while this is the player data, I want to be slightly more specific because I think that'll help clear up any possible confusion, especially in the future when you come back to this script. So instead of just calling these variables player data, I want to actually call them default player data. This is so that when we look back at this variable, we know that by default player data, we mean when the player joins the game for the first time, this is what their data will be set to. So now that I've renamed that variable, let's go ahead and update it right here and update it right here as well. And now, with that being said, that's all that we're going to do inside of this script, so we can go ahead and close out of that. We can also collapse the replicated storage because we're no longer going to be using that for right now at least. The next thing that we're going to do is actually update the player data service inside of our server script service, because inside of that script is where we'll be doing everything related to the player's data. So we'll go inside of the server script service, inside of the services folder, and then we'll go ahead and open up the player data service. Now, first things first, towards the top of our script, we already have a variable for the player service, but we want to get 2 additional services as well. First, we want to create a variable for the replicated storage, and then we also want to create a variable for the run service as well. Then, below our service variables, we want to create a few more. The first variable is actually going to be for a library that we're going to be using, which is called profile service. And now the profile service variable makes securely managing our players' data extremely simple, reliable, and easy. So let's go ahead and create a variable for this. We're going to call it profile service. Then we'll use require. And now this library is stored inside of the server script service and inside of a folder called libs. Now, there's 2 ways that we could require this library, and both ways work perfectly fine. The first way is we could say script.parent, and this would take us to the services folder, which is stored inside of the server script service. So then we would have to say parent once again. This would put us inside of the server script service. Then we can access the libs folder, and then we can access the profile service module script. Alternatively, what we could do is actually create a variable towards the top of our script for the server script service. And then instead of saying script.parent.parent, we could say server script service.libs.profile service. Now, both of those methods are perfectly fine to use, but since I did just create the variable for the server script service, I might as well keep it this way. I'm also trying to keep all these variables in alphabetical order, so I'm going to move the server script service down a little bit. Anyways, it's good that we now have this variable, and we will use it in just a second. But the next thing we want to do is create a variable for the player data module that we just created inside of the replicated storage. Now, we're actually going to call this variable data template because that really is what the variable is. It's mostly a template of the player's data that we're going to use for each new player who joins our game. And now, how do we actually get that module script? Well, we'll use require. Then inside of the replicated storage, we should have the player data module script. Okay, now that we've created those variables, let's go ahead and start setting up the profile service. Now, the first thing that we're going to do is create another constant variable, which we're going to call data store underscore name. And for the value of this, we're going to set that to a string. And more specifically, we're going to call this production. Now, we're going to add a comment there, and we want to say do not modify. And the reason for that is because if we change our data store name, that will effectively swap us to a different database where we will try to pull the player's data from, and you effectively will lose all of the player's data. So say, for example, you change this from production to production 2. Production 2 is a brand new database that we've never accessed before or stored players' data inside of. So of course, when we try to access players' data from this database, it will not exist, and their data will pretty much be reset because it's a brand new one. But don't worry, if you do change it, you can just revert it back to the previous name. So if we change it back to production, all of the data will still remain inside of the production database and it will not have been modified at all. So it's not like you permanently lose it or anything, you just have to change the name back to the previous one. Now with that being said, we're actually going to make a change to this variable. And I know that I just told you guys a second ago that the main difference about constant variables is that they don't actually change. So realistically, it might not have been the best idea to write this as a constant variable. Although I would kind of call this like a half constant variable because ultimately we will not modify this anywhere else in the code and it's not exactly meant to change, but we do kind of change it just a tiny bit one single time. Anyways, with that being said, the only time that we actually want to change the data store name is if we're working inside of Roblox Studio. If we're working inside of Roblox Studio, generally we don't want to hook up to the same data store that players are actively playing on. Because if we're testing out different things with our game, we may even want to wipe our own data or even do different things that can have a drastic effect on other players' data. So that's why when we're working in Studio, we basically want to contain everything we do inside of Studio to a separate database that other players are not attached to. So in order to do this, we're going to use an if statement. And now when the script runs, we want to check if it's being ran inside of Roblox Studio. And there's a really easy way to do that. We can use the run service for this because it actually has a method called isStudio, which will return whether the current environment is running inside of Roblox Studio. So now, if we are running this inside of Roblox Studio, then we'll go ahead and update the data store name variable, and we'll set this to testing. So when we're working inside of Roblox Studio, we'll be using the testing data store, and we can freely change or modify this string to give us fresh databases if we want to wipe our own data, basically. And we'll never have to worry about accidentally messing up the actual player's data of our live game. Cool. Now that we've got the data store name actually set up, let's go ahead and create the profile store. Now, you can think of the profile store as basically an easy-to-use data store. So basically, the profile service will handle all of the data store things and pretty much give us an API, which makes it really easy and convenient for us to use and work with. So we're going to create a variable called profile store. And for the value of this, we want to use the profile service, which has a function called getProfileStore. Now, the first argument that we want to pass through to here is our data store name. And the second argument that we want to pass through is the default player's data. So we'll say data template.default player data. So now we've created the profile store, and we'll of course use this a couple of different times. Like for instance, when the player joins the game, we'll use the profile store to actually get their data. But before we begin using the profile store, we still need to do a couple of different things. And the first thing that we're actually going to do is create a variable for holding all of the players' profiles. Now, to give you some insight into how player profiles actually work, whenever a player joins our game, we want to pull their data from the data store. And since we're using the profile service to do that, what we actually refer to the player's data as is actually their profile. So when a player joins our game, we're going to go ahead and use the profile service to get their profile, which will effectively download all of their previous data. But then we need to store that data somewhere in our code so that we can actually use and interact with it. So to account for that, we're going to go ahead and create a variable, which is going to be called profiles. And we can specify the type of this by using a colon. And now, like I said, the type of this variable is going to be a table. I should have been more specific as to what type of table this actually is, and that is a dictionary. So we're going to store key value pairs inside of here. And we can actually specify the key type by using square brackets. And now the type for our keys are actually going to be player objects. Then we can use a colon and specify the value type. And for the profile type, we can actually get that from the profile service module. So we'll say profile service. And the first type that's suggested to us is profile, and that's actually the one that we want to use. Now, one thing that we have to actually look at before we type out the word profile, we can see Roblox is actually displaying the type to us, but after the word profile, we can also see the word data surrounded in angle brackets. Now, this is pretty unusual and I would say quite advanced, but basically what those angle brackets mean is that this type actually accepts an argument that we can pass to it. And the name of the argument that it wants us to pass to it is actually data. And what it's referring to by data is the player's profile data, and more specifically, the data template that we actually created earlier, or really the type of the player data. So let's fully finish typing out the word profile, and now we can see that it's underlined in red, and that's because we haven't passed the argument to it that it wants. So to pass the type of argument, we'll also use angle brackets, and now inside of the angle brackets, we actually want to pass through a type to the profile type. And the type that we're going to pass through is the player's data. So we're going to say data template.player data. And now we've actually fully finished with specifying the type of the profile's variable. So this table is going to hold key value pairs, and we're going to insert the player as the key and their profile as the value. Now, like I said, it's very uncommon to actually see a type accepting another type as an argument, and you're probably confused as to why we even had to actually do this. And I'll actually explain that in just a second, but I think it'll make a little bit more sense once we actually begin sort of scripting the system out, so let's continue making our way towards there, and then we'll revisit this in just a minute. Since we've now specified the type of our profile's variable, let's then actually set it equal to a blank table. Now, the next thing that we're going to do is go ahead and create the function for creating a player's profile whenever they join the game. So to do this, we're going to scroll down in our script, and we're going to go right below the Create Leaderstats function and create a brand new function. This function is going to belong to the local table, and we're going to call this Create Profile. Now, this function is going to have a single parameter, which is going to be a player. And now, the first thing that we're going to do inside of this function is create a variable for the player's user ID. And we can get that by saying player.userID. Then we'll create a variable called profile key, which is basically just going to be a string which needs to be unique because we're going to use that key to retrieve the player's profile from the profile store. So we're going to set profile key to a string. And now the way that we're going to create this string is actually by using backtick symbols. If you're unfamiliar with where those symbols are at on your keyboard, look to the left of the 1 key. It might also be above your tab or below your escape key. And the reason that we're using backticks for creating our strings is because when we use backticks to create strings, we can actually directly use variables inside of here and easily combine them with our strings. If you have no idea what I'm talking about, it's a really nice thing to know, and it's super simple to learn. So if we want to use a variable inside of here, we need to use an open and closing curly bracket, and then inside of those, we actually specify what variable we want to use inside of here. And the variable that we want to use is the user's ID. Then outside of those curly brackets, but still in between the backticks, we can then type out the next part of our string. And I'm going to say underscore and then the word data. Now, just in case you're confused by this at all, let's say that the user ID variable is this number right here. Then what the profile key would actually come out to be is this string right here. So first it would be the user ID, and then we have underscore data, just like that. Now, if you never knew about this, let me know in the comment section down below if you just learned something new. And maybe smash the like button while you're down there. Anyways, now that we've created the profile key, the next thing that we can do is actually get the player's profile from the profile store. So we're going to create a variable called profile. And to get the player's profile, we're going to use the profile store. We want to use a method on the profile store, which is called load profile async. And what we need to pass through to this method is the profile key. So now we should actually have the player's profile, which means that we have access to all of their data. But the thing is, though, is that we want to make sure that we do actually have access to the player's profile. So we're going to say if not profile. And if we don't actually have the player's profile, what we're going to do is we're going to go ahead and kick them. And to kick a player, all we have to do is use a method on their player object, which is called kick. And the kick method actually accepts a message as a string, which we can pass to it if we want to include a message to the player as to why they've been kicked. And the message that I want to display to the player whenever we kick them at this time is unable to load your player data. Now, realistically, this should never happen unless you set your data up incorrectly or Roblox is having an outage. And if Roblox is having an outage and we're not able to access players' data, then we most likely don't want them to play on our game. Now, there's another really important thing that we need to do inside of this if statement, and that is use the keyword return. And the reason that we're doing that is so that it stops the function right there and it does not continue any further. And that's because we've kicked the player, so we don't need to try to do anything else in the create profile process. Now that we're at this point, though, we can guarantee that we do actually have the player's profile because of this if statement and because of the return statement inside of there. Now that we know that we have the player's profile, the first thing that we want to do with the player's profile is actually sort of set up the cleanup method for what we kind of want to do when the player leaves our game. Whenever the player leaves our game, we actually will use a method called release. Because once we release the profile, it'll actually remove the session lock from the profile, and their data will immediately be saved for the last time as well. But like I said though, when we do that, that's actually going to be when the player leaves the game, and to handle that, all we're simply going to do is call the release method on their profile. But what we want to do right now is sort of set up a cleanup function, which will do some other things when the profile has been released as well. So the method that we actually want to use on the profile is called listen to release. And now what this method actually accepts is a function. So we can go ahead and create an anonymous function inside of here. And now there's actually only two things that we want to do whenever we have released the player's profile. That is removing the player's profile from the profile table, and we also want to kick them as well. So let's get started with that. How do we remove the player's profile from the profiles table? Well, we would actually index the profiles table with the player because remember, that's what we're using for the keys. And then to remove a key value pair from a dictionary, we just have to set the value to nil and that will remove them. And like I said, we also want to kick the player as well. And we've already done that before, so we can just use the kick method once again. Now, I'm not going to include a message here because it's extremely unlikely that the player would actually be kicked for this reason. Because remember, like I said, the only time that we're releasing their profile is when the player leaves the game. And again, to bring us back to when listen to release is actually going to be used is when we actually use the release method on the profile. So you could kind of think of the listen to release method as sort of an event, because that's effectively what this method is doing. It's connecting this function right here to sort of a release event. Or you could even just think about it as to when we use the release method, then it automatically calls this method and uses whatever function we pass through to it. There's a couple of different ways that you can think about it, but I'm just hoping that everything I said makes it easier to understand and I didn't just further confuse you. Anyways, now that we've set up what we do to clean up the profile once we're done using it, the next thing that we want to do is associate a player's user ID with their profile. And to do this, we need to use another method of the profile. So we're going to say profile, and the method that we're going to use is going to be called add user ID, and we want to pass through the user's ID. Then after that, we're going to use another method of this, which is actually going to be called reconcile. Now, reconcile is one of my favorite features of the profile service. Basically, whenever we make changes to the player data template that we created earlier, so whenever we actually change the structure of the player's data, like say we implement a brand new quest system, and we never had quests before. When we add the quest data to the player data table, the reconcile method will actually handle updating the player's data and adding the quest data to their data. So it basically fills in all of the missing variables inside of the player's profile data with any of the new things from our player data template. And now that we've handled all of that, there's only a few more things that we're going to do. The next thing that we want to do is actually add the player's profile to the profiles table. So we're going to say profiles, and now how do we add a value to a dictionary? Well, we'll index the dictionary, and what are we going to use as the index? Well, we're going to use the player, and then what are we going to set the value of this key value pair to? Well, that would be the player's profile. And the last thing that I want to do inside of this function is go ahead and create the player's leader stats as well. So we're going to go ahead and say local, and then we'll call the create leader stats function passing through the player. Now, of course, we still have to update the leader stats function to incorporate the player's data, and we'll do that in just a little bit. But before we do that, I want to go ahead and hook the create profile function up to when we're actually going to use it. And like I said from the beginning, we want to create the player's profile whenever they join our game. So we can go ahead and replace where we call create leader stats with calling create profile. In addition to doing that whenever a player joins our game, we also want to do that for all the players who might also currently be in our game when the script loads for the first time. So let's go ahead and call it inside of this for loop as well. Now that we've done that, we also want to create another function, and we're going to use this function whenever a player leaves our game. So we're going to go down towards the bottom of our script, and we're going to create a brand new function, which is going to be a part of the local table. And we're going to call this function remove profile. And all it's going to do is accept a player. Now, whenever we call this function, the first thing that we want to do is actually get the player's profile. To do that, all we have to do is index the profiles variable with the player. Then we want to check if we've actually gotten the profile or not. And if we did get the profile, then what we're going to do is call the release method on it like we talked about earlier. And that's actually all that we're going to do inside of this function. So let's go ahead and use it towards the top of our script. And now, when do we want to use it? Well, of course, we want to use it whenever the player is leaving our game. And to determine when a player leaves our game, we can actually listen to the player removing event. And whenever that happens, we're going to go ahead and call the remove profile function. Now, there's one more thing that we want to do before we modify the create leader stats function. And that's actually going to be creating a function for easily accessing the player's data. So below our onStart function and above our create leader stats function, we're going to create a brand new one. And this is actually going to be a part of the shared table. And it's going to be called getState. And it's going to have a single parameter, which is going to be a player. Now, if you're unfamiliar with the word state, you could think of this exactly as the word data. So you've heard me talk about players' data and getting the players' data from their data store. Anytime you hear the word data, you can also think of the word state. So I would say the exact same things, like we store the player's state on their profile, which is stored inside of the data store. Now, if you don't feel comfortable with the word state, you can replace that word with the word data anywhere we actually use it. But in certain parts of this series, you will be seeing me use the word state rather than always using the word data. Now, in order to get the player's data or to get the player's state, what we're going to do is we're going to create a variable for the player's profile. And again, to get that, we index the profiles variable with the player. Then if we do get the player's profile, what we want to do is we want to return their data. So we're going to return their profile, but we're going to return a variable on the profile table called data, which is of the player data type. So just to clear up any confusion, we can index the data type and see what is actually on this table. And so far, we have a property called stage, which is a number, and we have defs, which is also a number as well. And where does that come from? Well, that comes from our data template that we created earlier. And now the data property actually brings us back to earlier when I said that I would further explain why we pass through a type to this profile type right here. So the reason that we need to pass through the data template player data type to the profile type right here is because if we don't pass through that type there, then when we use the profile data variable, the profile service would not actually be able to accurately know what the data type would actually be inside of here. So that's why we need to specifically tell this library, hey, this is what our data template looks like, so make our job easier in Studio whenever we're working with that specific data. So anyways, getting back to actually working on the getState function, that's what we want to do if we do actually get the player's profile. We want to go ahead and return their data. And now at the end of this function, we'll also say return nil as well, just in case we're actually unable to get the player's profile. And now that we finished creating this function, we're actually going to go ahead and use it inside of our Create Leaderstats function. But I quickly want to point out that for the last little while of this video, you've actually been watching a re-recorded version of this. Now, I didn't want to re-record the entire episode because the changes that we made were very, very small. So while you continue to watch this video, your code towards the top is going to look slightly different than mine, but the only actual difference would be right here. So when I did my first recording of this is actually how I handled the profiles variable at first, because I actually didn't realize that the profile service gives us a profile type. So this is the old method, which you're going to see as you continue to watch this episode. Keep in mind that you can completely ignore that and you want to leave your profiles variable looking just like this. Again, I re-recorded this last section of this video, but I didn't feel like it was necessary to re-record the entire thing, so for the rest of the video, do not let yourself get confused by this, and just in case anybody does, I left a link down below in the description which you can go and view the entire contents of this script for completely free as well, to clear up any possible confusion that can come from this. And I do apologize for doing this, especially so early on in the series. I just wanted to make the improvement, and I didn't want to re-record the entire video because that would be a lot of time wasted. With that being said, we're going to resume for where we were previously at. With that being said, let's go back to the Create Leaderstats function and update this. Now, the first thing that we'll do inside of this function is create a variable called state. And to get the player's state, we'll go ahead and use that function that we just created. So share.getState, and then we'll pass through the player. Now, realistically, we probably don't have to check if we actually did get the state here because we should actually always get the state here, but we'd rather be safe than sorry. So we'll say if not state, then, and then we'll return to stop the function right there because we did not get the player's state, so we don't actually want to do anything here. Anyways, now that we know that we have gotten the player's state, when are we going to use it? Well, we'll use it right here where we set the value of the stage. So what are we going to set the value of the stage to? Well, we'll use the state for that, and we'll actually set it to the stage stored inside of the state. Now remember earlier when we created the player's data, we added two keys to it. We added the stage and defs as well. Let's go ahead and add another number value to our leader stats as well to display the amount of defs that the player has incurred. So we'll just go ahead and copy and paste this. Then we'll go ahead and rename this to be called a def. We'll rename all of these variables as well. And then we'll also rename this as well. So we'll say defs. And then to set the value, instead of setting it to the state.stage, we actually want to set it to state.defs. And now that's all that we're going to do inside of this function. So when we create the player's leader stats, it'll be updated with their real data. And if you're thinking, do we have to call this function somewhere? Don't forget, we already do call it at the very end of the create profile function. Now, another thing that we want to do inside of here is actually create a bindable event, which we'll use to fire off to other scripts and communicate to them that the player's profile has just been loaded. Now, you might be wondering, why would we create this? The reason that we would want to be able to listen to an event for when the player's profile has been loaded is because we can actually think of that as pretty similar to the player added event. And there's a lot of different times in our script where we will actually use the player added event. And when we use that function, we also intend on actually using the player's data. And the reason that we can't just use the actual player added event is because when do we actually load the player's data? Well, we do that by listening to the player added event. So if two different scripts are using the player added event, like let's say this player data service where we actually load the player's data and that other script needs to access the player's data, we're unable to guarantee that the player data service would actually load the player's data before the other script that's also listening to the player added event is trying to access access that data. And I hope that makes sense. Let me try to give you one more explanation. If we have two different scripts, let's just say that they're both services, so they're just our standard module script that we've been working with this entire time, and inside of those scripts, they both use the player added event. One of those scripts that listens to the player added event loads the player's data during this event, while the other script uses the player added event, and when that event is triggered, that script will try to access the player's data. Since the player's data is also being loaded by listening to this event, we're unable to guarantee that their data will actually be loaded and put into the profiles table before the other script actually tries to access it. So that's why we want to create a bindable event to communicate to all other scripts that the player's data has actually been loaded. And we can even think of that event as an alternative to the player added event, because of course we would fire off the profile loaded event shortly after the player has been added to the game. Now, creating this bindable event is extremely simple. Above our onStart function, we're going to go ahead and create a brand new variable, and it's going to be a member of the shared table. This variable is going to be called profile loaded, and for the value of this, we are going to create a bindable event. So we're going to say instance.new, and then for the class name, we're going to say bindable event. Now, if you're intimidated at all, or you feel like you don't know what a bindable event is, if you already understand what the player added event does, or what the player removing event does, you can literally think of a bindable event in the exact same way. The only difference is that we actually have control of when this event is fired. So rather than Roblox handling the event and firing it off for us, we can actually choose when this event is triggered and script that into our game. Now, just to give you an example, if we go inside of our onStart function, we can go ahead and type out shared.profileLoaded. And now if we wanted to connect to this profile loaded event, what we would do is actually get the event property of the bindable event. And now that we've actually gotten the event, we can go ahead and use the connect method like we would any ordinary event that we connect to. And with this connect method, we'll go ahead and create an anonymous function. But a cool thing about the events is that they can actually be passed data like any ordinary event. So we can add a parameter here, which would be called data, and we can set that to the type of data template.playerData, and then we can actually go ahead and use the player's data, for example. Now, of course, when we use the profile loaded event and we fire or trigger this event, we would actually need to pass through the player's data. Now, we're not actually going to be using any of this code here. I created this because I wanted to make it a little bit easier to understand and hopefully help my explanation of bindable events. Again, just to summarize all of that, bindable events can be thought of as any other event, similar to the player added event or the player removing event, but we're given the option of when that event is actually fired off or triggered. We can connect to it like we would any other event, and we can even pass through data using that event as well. So with that being said, I'm going to delete all of those lines of code, and now let's actually use the profile loaded event. And let's think, when do we want to trigger this event? Well, we would want to trigger this when the player's profile has actually been loaded. And when do we load the player's profile? Well, that is inside of the create profile function. So now if we scroll all the way down, we can see that we add the player's profile to the profiles table, and then we create the player's leader stats. Now, after we've done all of those things, we definitely know that we have actually received the player's profile. So let's go ahead and fire off that bindable event. We can do this by saying shared, and then typing out profile loaded, which is the name of the bindable event, and then we can use the fire method. Now, for the arguments of the fire function, we can include any data inside of here that we want all of the listeners to have access to when we trigger this event. And the only data that I actually want to pass through with this event is the player whose profile has been loaded. Now that we've set up this bindable event inside of the player data service script, let's go ahead and actually use this in one of our other scripts so that we can get a better understanding of it. We do have a few more things to actually do inside of the player data service script, so we will come back to this in a minute. But until then, let's go ahead and modify another service, and we're actually going to modify the respawn service. Now, inside of the respawn service, we want to go ahead and create a variable for the player data service. So I'm going to go ahead and create a variable for the server script service, and then I'll go ahead and create a variable for the player data service. And of course, to get that, we would use require, then we would say server script service.services.player data service. Now that we've gotten the player data service, we can look inside of our onStart function and we'll replace our current usage of the player added event. So above it, we'll go ahead and say player data service.profile loaded.event. And now that we've gotten the event, let's go ahead and connect that to an anonymous function. Now, this function will receive a player, so let's specify that parameter there. And now we can literally just go ahead and copy and paste all of the code that we performed inside of the player added event and paste that directly inside of our profile loaded event. And now that we've done that, we can remove where we connect to the player added event. Now, that's not the only thing that we want to do inside of here. We actually want to update the respawn player function a little bit to access the player's data directly from their profile and use that rather than relying on the leader stats. Now, we could continue to rely on the leader stats, but I would always prefer to actually rely on the player's data table rather than relying on the leader stats. And I think it's also a great lesson to show you how to do this as well. So let's just go ahead and delete that variable as well as the if statement, and then we'll create a variable inside of here called player state. You could even call this player data instead, but throughout this series, you'll probably be seeing me use the word state and data interchangeably. With that being said, to get the player state, all we have to do is use the player data service and use the get state function and pass through the player. Now, we want to confirm that we did actually get the player state, because if we didn't, then we want to stop the function right there. So if we go down to where we create the stage variable, we can now guarantee that we have actually gotten the player state. So let's update the value that we actually set this variable to. Instead of using the leader stats, we'll go ahead and use the player state, and then we'll simply use the stage value. Now that we've done that, we can also change the stage variable up a little bit, because we don't actually have to specify the type of this variable. The reason for that is because Roblox Studio knows that the stage key is actually a number. Although if you hover over the variable itself, it will say any. I'm not sure why, but if you were to actually type out stage, for example, it displays the type right there, which is number. So yeah, do not believe the hover over text. Studio knows that stage is actually a number, not any. And with all that being said, we are done with modifying the respawn service, which now relies on using the actual player's data rather than using the leader stats, which is fine to use, but again, I would really always recommend using the actual player's data rather than ever depending on the leader stats. So let's go ahead and exit out of the respawn service and go back to the player data service. Now, if we go back towards the top of our script and we look at what our shared functions are, we have onStart, which of course no other module would actually use the onStart function, but we do also have the getState function, which other modules will actually use. Something that we're missing though is that we don't have anything created for easily modifying the player's data. Here's an example of one of the things that we could do. We could create a function which is called updateStage that would accept the player and the brand new stage that they've reached. Then what we would do is get the player's profile and then actually update the player's data. So we would change the value of the stage key to the brand new stage that the player has reached. The thing with this though is that do we want to create a function for every single different piece of data that we want to modify on the player? And the answer to that is no. There is a much better way to handle this. So I'm going to remove this function and we're going to come back to the player data server script in just a second, but we want to actually create a module script inside of the replicated storage for handling updating the player's data. The reason that we're creating this logic inside of a separate module script is because it will help prevent the player data service from getting too congested with a bunch of different things, and we'll also use that function on the client as well in future episodes. So we want to go inside of the replicated storage and then we want to create a folder inside of here. We're going to call this folder functions because inside of this folder is where we'll store module scripts, which will actually just be functions that we can quickly and easily use in other scripts. So inside of here, we'll go ahead and add a brand new module script and we'll rename this to be called update state. Now, this module is going to be a little bit different. Rather than returning a table, which contains a bunch of different things inside of it, we're instead just going to return a function. Now, this function will have parameters and we'll do some things inside of it, but we need to do a few things before we actually get around to creating it. The first thing that we want to do inside of here is create a variable for the replicated storage. And the reason for that is because we actually need to access the player data module. So we'll go ahead and create a variable for that called player data. And to get the player data module, we'll say replicated storage dot player data, just like that. And now the reason that we need to require the player data module is only because we actually want to use the player data type that we created inside of that module as the first parameter of this function. So we're going to call the first parameter player data, and for the type of that, we will set that to actually the player data type that we created inside of the player data module. Now, we will also have a second parameter inside of here, but we need to go ahead and actually create a brand new type before we do that. So let's go ahead and create this brand new type. This type will be shared with other module scripts, so we want to use the keyword export. Then to create the type, we need to use the keyword type, and now we need to specify the name of the type, which we will call update state action. And now the value of this is going to be a little bit different than something you've probably done before. Basically, we want to create a bunch of different tables inside of here. So this would actually be called a union of tables. Now again, I expect this to be kind of confusing, but just follow along with me. We're going to create a table inside of here. Now, this table is going to have two properties. The first property is going to be called type, and we're going to set that to a string literal. And what I mean by this is we're actually going to specify the string as a value here. So we want this to be called update stage. And now this table will have another property, which will be called amount. And the type of amount will be a number. Now, just to touch on the word type, the color of it is different than a normal property like amount here, for example. And what we mean by type is you could even think about this property as, say, the name of the action instead of type. I went with type because it just clicks in my head perfectly what I mean by type, but again, it pretty much exactly just means name, or you can even say action. We're really just using it to indicate what the action actually is here. But again, I'm going to name mine type. Now, we've just created our first state action, and we will add more actions to this, but let's go ahead and actually use this action to help you further understand exactly what we're doing. Going back to our function, we'll now add our second parameter to this, which we'll call action. And the type of this will be the update state action type that we just created. So when we use this function, we're going to pass through the player's data as well as the specific action that we want to perform on the player's data. So since we're passed the player's data to this function, we can easily make changes to it, and we can use the action to determine what changes we actually want to make to it. So let me show you what I mean. We're going to create an if statement, and we'll use the action argument, and we want to check what the type actually is. So now, if the action type equals update stage, then we want to do something specific to the player's data. And what do we want to do to the player's data? Well, what we're going to do is modify the stage property of the player's data, and then we will increase that by the action.amount. Now, I'll probably re-explain this a few times because I think at first this might be a hard topic to understand, but please, if you feel like giving up now or you feel like this is pointless or over-engineering, please do not give up and really try to actually understand what we're doing here. I have to say that this is almost my favorite way of handling player data because it's honestly so simple and easy to do, and it's so much cleaner than all the previous ways that I've handled it. So let me show you an example of what it would look like when we actually call this function. So let's say, for example, that I wanted to modify the stage that the player is currently on. What I would do is create a variable called action, and we would specify the type of this to update state action. Then we would set that equal to a table, and now inside of this table, I would set the type of it equal to update stage. Then I would specify the amount and basically say that I want to increase their stage by 1. So now that I've actually created my action, then I can go ahead and actually call this function. Now, of course, I can't actually call this function from inside the module script, but just imagine that we created this function and it was called test, and now we need to pass through the player's data, and then we pass through the action to it as well. So again, calling the test function is supposed to represent actually calling this function right here. So when this function's called, it'll receive the player's data and also the action as well, specifying what this function needs to do in order to accurately modify the player's data for how we intended. So it'll check the type of the action, it'll see that it's update stage, and then it'll go ahead and add the amount to the player's current stage. So hopefully that made it slightly less confusing. We will actually be using this function in just a minute, but I wanted to give you that example right there to hopefully make it easier to understand before you feel way too confused. With that being said, we now want to go ahead and add a second action. Remember, I said that this is going to be a union of tables, and what union means is basically just a collection. It's going to be a type which can be a variety of different tables. Now, to be able to add the second table to this that we want to, we need to use the vertical bar symbol. You can kind of think about it as a replacement to the comma symbol that we commonly use when we say add properties to tables or do different things like that. When it comes to types though, we don't use the comma for that. We instead use the vertical bar here. So now that we've added the vertical bar, we can go ahead and add our second table to this type. Now, I don't like Studio's default formatting for this, so I'm going to go ahead and kind of move it a little bit. Anyways, inside of this table, we want to go ahead and add the type property, and we'll call this update defs. Then we want to add the amount property, which again will be a number. And then I'm going to go ahead and reformat this to look a little bit nicer, and there we go. So now we want to go back to our function, and then we're going to create an else if statement inside of here. And now we want to check if the type of the action is actually update defs. And if it is update defs, then let's go ahead and update the player's defs. So we would say player data dot defs, and then we'll go ahead and add the amount that was included in the action. So now, with that being said, that's all that we're going to do inside of this module script for right now. We can go ahead and close out of that and collapse the replicated storage and go back to the player data service. Now, we want to go back towards the top of our script and go ahead and require that module script that we just created. So below our data template variable, we'll go ahead and create a new variable, which will be called update state, and we'll set that equal to require replicated storage dot functions dot update state. And now let's go ahead and actually use this. So below the shared get state function, we want to create a brand new function, which will again be a part of the shared table, and we'll call this update state. Now, the first parameter will be the player that we want to update the state of, and then the second parameter will actually be the action. And to specify the type of this, we need to use the update state module, and more specifically, the update state action type that we just created. So inside of this function, the first thing that we want to do is get the player's profile. So we'll create a variable called profile, and then we'll index the profiles variable with the player. And if we do not get the profile, then we'll go ahead and stop the function right there. But now, if we do actually get the player's profile, then what do you think we want to do? Well, we want to actually use the update state function that we created in that module script earlier. And because of how we created that module script, it might feel a little bit weird because we're requiring that module script, and then when we actually use it, we're just using it as a normal function. So some of you might be extremely confused by this and might not be too big of a fan of this, but I think it's also a great lesson to see the wide variety of things that you can actually do with module scripts. So we're basically just using the update state module script as a normal function. So we include the opening and closing parentheses after saying update state. And then for the first argument of this, we're going to go ahead and pass through the player's profile data. And for the second argument, we want to actually pass through the action. And that's really all that we need to do here to actually update the player's state, because all of that is handled inside of the update state module. So now anytime we actually modify the player's data, we will always be using this specific function from the player data service to do this on the server side. We should never directly access the player's profile from another script and then make modifications to their data that way. Instead, we always want to go through using the update state function. Now, since we're only ever going to use this function to modify the player's data, we also need to account for the player's leader stats. So we also want to update the player's leader stats inside of here as well. And how can we do that? Well, we can handle that similar to how we handle updating the player's state. So we'll use an if statement and we'll check the type of the action. And now if the type of the action equals update stage, then what are we going to do? Well, we can go ahead and modify the player's leader stats. So we'll say player.leaderstats.stage.value plus equals and then action.amount. Now, of course, we see a red underline here because Studio doesn't know that we have added leader stats to the player. I think in the last episode I went over that technically we should use find first child and then make sure that that actually exists, but this is perfectly fine as well because the player should always have their leader stats if their data is ever being updated anyway. Now, instead of just update stage, we also need to account for update defs as well. So we'll create an else if statement here. We'll check if the type of the action is update defs. And if it is, then let's go ahead and update the leader stats for that as well. So we'll say .defs, and then we'll add the action amount to that as well. And there we go. We're now actually handling updating the player's state as well as their leader stats. So with this function being created, where can we use it at? Well, we can actually use it inside of our progress service that we created in the last episode. But we need to do one more thing before we actually modify the progress service. So let's go back towards the top of our script. So before we even create the data store name variable, another thing that we want to do inside of here is we want to re-export the update state action type that we created in the update state module script. The reason for that is because we created the update state action type inside of the update state module. Now, if we wanted to ever use this type, ordinarily, we would have to require this module script just to be able to use that type, even if we didn't care about the functions or anything else like that inside of here. Rather than doing that though, there's an even simpler way of actually handling this, because every time we want to modify the player's data on the server side, we're going to require the player data service. So rather than having to require both the player data service and the update state module just to use the type from that module, we can instead do something to allow us to only have to require the player data service. And what can we do? Well, we can basically re-export the type that we're already exporting from a different module script. And the way to do that is by basically just making the type, exporting it, and then setting it to that exact type. So we'll say export type, and then we'll type out the name of the type that we want to export, like we normally would. So we'll say update state action, and we'll set that equal to the update state action type. And by just doing that, whenever we require the player data service module, we now have access to the update state action type that we originally created inside of the update state module script. So we no longer have to require the update state module script when we actually just want to use the update state action, of course, as long as we're requiring the player data service. And now with that being said, let's go ahead and update the progress service. Now, inside of here, we of course need to require the player data service. So let's go ahead and create a variable for the server script service. And now that we've created a variable for that, we can go ahead and actually require the player data service. So we'll say require server script service.services.player data service, just like that. Now let's take a look at when we actually modify the player's data, and that's inside of this if statement right here. So once we get the stage that the player has progressed to, then we update their leader stats. But now, instead of updating their leader stats, we want to actually update their player data. So now, the first thing we want to do inside of here is actually create the action. So we're going to go ahead and create a variable called action, and we want to specify the type of this variable. And we'll use the player data service, and we want to set the type of this to the update state action. And now for the value of this, it's going to be a table. And inside of this table, we need to specify the type property, which of course would be update stage. And then for amount, we're going to say 1 because we want to increase the player stage by 1. So now that we've created the action, let's go ahead and actually update the player state by using the player data service and the update state function. We'll pass through the player, and then we'll pass through the action. And there we go. We've now actually updated the player's data. Now, the thing is, though, is that in the last episode, we really didn't fully create the setup spawn locations function. We kind of just got it to a point of being functional. So because of that and the changes that we just made, it probably wouldn't function exactly how we intended to. This would allow players to touch the exact same part and then increase their stage. They wouldn't even need to progress to the next stage before reaching it. So we can make a slight change to this to kind of account for that, at least for right now, before we actually fully finish creating this function. So what we want to do is we want to to make a quick check to determine if the stage that the player has just reached is actually greater than the stage that they were previously on. So in order for us to be able to do that, we need to go ahead and actually access the player's data. So let's create a variable called player state. To get the player state, we'll use the player data service and the getState function and pass through the player. Now, of course, if we do not get the player state, then we want to stop the function right there. And now let's create a variable for the stage that the player is currently on. So I'll call that player stage, and we'll set that equal to player state.stage. Now, the next thing that we want to do is create a variable to determine if the stage that the player has just touched is actually the next stage that they should progress to. So we'll create a variable called isNextStage. And to determine if this is the next stage, what we would do is we would actually use the player stage variable that we just created, and make sure you're using the player stage, not the player state variable, because it's very easy to make a spelling mistake right there. And then we would just add 1 to that, because of course that number would be the next stage that they're intended to go to. And now since we know the next stage that the player should go to, we can check if that is equal to the stage that the player has actually just reached. And now if it is not the next stage, then we want to stop the function right here. So if not is next stage, then return n to stop the function right there, because the player has not reached the next stage that they should have. And with that being said, we're actually all done with handling that inside of here. So we've just done a lot of stuff. Let's go ahead and make sure our game is still working as it originally did. One thing that we want to make sure of is that we do have the data services enabled. And we did do that in the last episode, but just in case you forgot, make sure you go to the Home tab, select Game Settings, then go to the Security tab, and make sure that you have enabled Allow HTTP Request and Enable Studio Access to API Services. And as long as you have both of those things enabled, then we can go ahead and play our game and test this out. Now, as we're loading into our game, we should see something printed to the console for Profile Service, which says Roblox API Services available, data will be saved. So we know that data will be saved, and now when we're in our game, we can see our leader stats right there, and we can see that we did actually spawn in on the first stage, so that's working perfectly. Let's go ahead and progress to the second stage and see what happens. When we progress to the second stage, we can actually see our leader stats have been updated. Let's go ahead and respawn real quick and see if we respawn at the right stage. And now when we respawn, we can see that we have respawned actually at the right stage. So now let's go ahead and progress over to the third stage to guarantee that this is all working. And we can now see the leader sets have been updated, and this is actually all working as it should. So with all that being said, that's going to be it for this episode. Like I said in the outro of the first episode, everything that you see during these first couple of episodes should function exactly as you see in my video directly inside of Roblox Studio. So if you were to use the actual Roblox player to play the game, you may have different experiences, but that's just because we haven't fully implemented all of these systems yet. Anyways, if this video did work for you, please go down below in the comment section and leave a comment letting other people know that it did. Like I said, it's super common for people to only leave a comment if they experience an issue or if the episode didn't actually work for them, so this is extremely helpful and I really appreciate it. Additionally, if you want to gain access to all the scripts and the game that we made in today's episode, as well as support me and gain access to a ton of other resources that you can even use in your own game, then feel free to go down below in the description and visit my Patreon or my own website, monster.dev, to get access to all of those things. And with that being said, that's going to be it for this episode. Hopefully you have a great day, and I'll see you guys in the next episode.